Good day, math learners. For this video, I am going to discuss on the simple probability. When we say probability, it is a branch of mathematics concerned with analyzing the chance that a particular event will occur. It is a mathematical method of random phenomena. It is a phenomenon with random manifestations. Today, not only mathematicians are interested in the topic, but also economists, businessmen, scientists, and others. The study of probability involves the use of certain terms. First, we have experiment. It is an activity by which the observation or measurement is obtained. Another one, we have sample space. It is the set of all possible outcomes of a given experiment. Another one, we have sample point. It is one of the possible outcomes in a sample space. And lastly, we have event, a collection of sample points or possible outcomes of an experiment. Let us take our dice activity as an example. If we have this statement, roll 2 dice and have both odd numbers turns up. The phrase roll 2 dice refers to an experiment in which it is a process that produces an outcome which can be random or not. And this both odd numbers refers to an event, which is the desired outcome of an experiment. So, in getting the probability of an event, we have to consider that there must be an experiment to produce outcomes and calculate for its probability. When we say probability of an event, or P of E, it is the ratio of the number of possible outcomes in the event, or N of E, to the number of all outcomes, or N of S, in the sample space. In symbols, P of E is equal to N of E over N of S, or the number of possible outcomes of event E over the total number of outcomes in sample space. Probability of an event is the quotient between the number of outcomes of a desired event and the entire sample space of the experiment. So let us discuss this using our dice example, which is roll 2 dice and have both odd numbers turned up. So from the definition of probability, we write P of both odd numbers, since this phrase is considered as the event of our experiment, N of both odd numbers, or the number of possible outcomes if that would be both odd numbers, over the number of possible outcomes when we roll 2 dice. Again, P of both odd numbers is the probability of an event. N of roll 2 dice is the number of outcomes of the experiment. So, our solution is this. N of roll 2 dice, or the number of possible outcomes when we roll 2 dice, is equal to 6 times 6. We use fundamental principle of counting, or FPC, to do this because it involves 2 independent events. The first 6, which is this, indicates that first die has 6 different faces. We also write 6 here because it is the same for the second 6. It has 6 different faces. And the number of all possible outcomes when we roll 2 dice is equal to 36. We have identified earlier the number of all possible outcomes, which is 36, when we roll 2 dice. This time, we will identify the number of outcomes that both odd numbers turn up. Again, the number of possible outcomes when both odd numbers turn up for 2 dice is the number of outcomes of a desired event. So, here is the solution. We have 3 times 3. We use fundamental principle of counting, or FPC, here to do this because it involves 2 independent events. This first 3 indicates that first die can possibly have outcomes 1, 3, or 5. This is also 3 because it is the same for the second 3. We can have outcomes 1, 3, or 5 here. And if we are going to get its product, the answer would be 9. So, there would be 9 possible outcomes when both odd numbers turn up for 2 dice. So, let's use the answers that we got earlier. For the number of possible outcomes when both odd numbers turn up for 2 dice is equal to 9. For the total number of possible outcomes when we roll 2 dice is equal to 36. Now, we are going to use the concept of the probability, which is this. And then we are going to substitute the values of this one, which is 9, and this one is 36. So we have 9 over 36. Or get its simplest form, and that is 1/4. As an interpretation, this means that there is 1 out of 4 possibilities that both odd numbers will turn up if 2 dice were rolled. So let's talk about the probability scale. We have these 3 values as our basis for the interpretation of the concept of the probability. We have 0, 0.5, and 1. If the probability of an event A is equal to 0, this means that there is no chance that event A will occur. If the probability of an event A is equal to 0.5, this means that there is 1 chance out of 2 that event A will occur. This chance of success is half. If the probability of an event A is equal to 1, meaning that event A will occur each time the experiment is done. Take note, this probability scale tells us that the chance of occurrence of any event A is only between 0 to 1. For example number 1, 2 fair coins are tossed. What is the sample space? What is the probability that 2 coins will both turn up heads? Here is the solution. You can get the sample space using table of values, tree diagram, or systematic listing. So this time, we use the table of values. Our experiment is tossing 2 coins. The sample space of tossing 2 coins contains head and head, head and tail and head, tail and tail. The event would be 2 heads to appear, or both coins turn up heads, and it is head and head, which is in our table. As you can see, the number of sample space, or the total possible outcome, is 4. So that is why we use this notation. N of S is equal to 4. And the number of both coins turned up head is only 1. So we have this notation, N of E is equal to 1. Using the concept of probability, which is P of E is equal to N of E over N of S. Substitute the values that we have earlier and it will become 1/4. So we conclude that the probability that two coins will both turn up heads is 1/4 or 0.25 or 25%. For example number 2, if a card is drawn randomly, form a deck of 52 cards. Find the probability of getting a red card, a heart card, an ace card, a face card, and a number card. In a deck of cards, there are 52 as the total number of cards. There are 26 cards for red cards, 13 cards for heart cards, 4 cards for ace cards, 12 cards for face cards, and 40 cards for number cards. So our solutions to get the probability of getting a red card is P of R, or the probability of red card, is equal to the number of the red cards over the total number of cards, or 26 divided by 52 is equal to 1/2. For P of H, or the probability of heart card, is equal to the number of heart cards over the total number of cards, or 13 over 52, it is equal to 1/4. For P of A, or the probability of ace card, is equal to the number of the ace cards over the total number of cards, or 4 divided by 52 is equal to 1/13. For P of F, or the probability of face cards, is equal to the number of the face cards over the total number of cards, or 12 divided by 52, the answer is equal to 3/13. And for P of N, or the probability of number card, is equal to 40 divided by 52 is equal to 10/13. For example number 3, in tossing a coin, find the following: probability of getting a head and probability of getting a tail. Here is the solution. In tossing a coin, there are only 2 events that can occur: getting a head or getting a tail. So we will identify the number, or the total number of possible outcomes for tossing a coin, and that is equal to 2, the head and the tail. The number of head is equal to 1, and the number of tail is equal to 1 as well when we toss a coin. Using the concept of probability, P of H, or the probability of getting a head, is equal to the number of head over the total number of possible outcomes when we toss a coin, and that is equal to 1/2. And P of T, or the probability of getting a tail, equals the number of tail over the total number of possible outcomes when we toss a coin, and that is equal to 1/2. Thank you for listening, math learners. I hope that you will answer all the activities that we have prepared for you. Keep safe and God bless always.